Okay. Now this is the equation number 11 that gives the wave function for the free particle and the perturbed particle in the crystal potential. Here what happens? E to the power ikx is taken inside and you can get this one as e to the power I into k minus 2 pi n by a into x. So that k minus 2 pi n by a is taken as kn. So that what we have written here, that is equal to b naught, this into e to the power ikx plus gamma into sigma bn e to the power ikn x. Now what you have to do is, our aim is to substitute the value of xi of x in equation number 11, that in equation number 4, that is the d square xi by dx square plus k naught square plus gamma f of x of xi of x is equal to 0. That means we have to first differentiate xi of x twice with respect to x. Dxi by dx is equal to b naught differentiation of e to the power ikx, ik into e to the power ikx plus gamma sigma differentiation of this ikn into bn into this. Again you differentiate it, b naught into ik, I square is minus k into k square e to the power ikx. Similarly here ikn into ikn, right? So minus kn square. So this is the d square xi by dx square. And also you know that from equation number 5, f of x is equal to sigma cn into e to the power minus 2 pi inx by a. Now what you have to do is, in equation number 4, you have to substitute the value of d square xi by dx square. Then in the place of f of x, you have to substitute cn into e to the power minus 2 pi inx by a. Then in the place of xi of x, you have to substitute this. Then after substitution, you will get these things. So that means, see here, in the last term, you have to simplify this. And when you are getting this term, sigma, this is for the last term, you may think that from where this n dash comes, right? See, 1 bn, that is due to what? From here, right? In the expression you have. Then another cn term comes due to this. In both the expression you have the n. But in this expression, if n is equal to 1, in this expression n need not be equal to 1, it may be 2. Therefore, in both the expressions n need not be same, it may be different. Therefore, in order to understand that one, just I have replaced in the expression of xi of x, bn is replaced by bn dash, that's all. So n dash is also an integer, n is also integer, but n is not equal to n dash, need not be. Okay. So then here kn minus this 2 pi n dash by kn is replaced by k minus 2 pi n by a. So remember here, that is equation number 13. Okay, have you understood? So remember here, you try to substitute all the values. Okay, substitute all the values. Then what you have to do, in the last expression, when bn and cn comes, in one place you replace n by n dash. That's all. Only to make the difference that here this n and this n need not be same. So then for simplicity, just in the next step, just you neglect this term. Okay, only approximate relation, let us we get it for our simplicity. After neglecting, collect the terms containing e to the power ikx. Similarly, collect the terms containing e to the power I k n x and this one. Okay. So finally, what you will get? This is the expression. That is the equation number 12. Here kn is equal to k minus 2 pi n by a. Fine. Now, you have considered the equation number 12. In this equation number 12, kn is equal to k minus 2 pi n by a. That you call as equation number 13. Now, what we will do is, see, perturbation effect is negligibly small. That means what? Gamma tends to 0. You consider the limit gamma tends to 0. For first approximation, okay, and the limit gamma tends to 0, in equation number 12, you neglect the term gamma square. Okay, first of all, just neglect the term gamma square. We will consider that one later. Okay, therefore, only for first approximation means consider only the term containing gamma and this. Okay, neglect gamma square. So, now that means when you neglect this, only these two terms left. Then for the remaining part, what you have to do is, you multiplied with the e to the power minus I k m x. After multiplication, you have to integrate the equation with the limit 0 to a. That is what you are getting now. Don't consider this. B naught into k naught square minus k square, right, into e to the power. What you are getting now? E to the power I k x into e to the power minus I k m x. That means what you are getting? E to the power e to the power I k minus km of x. What happens? See, km is equal to what? K minus 2 pi m by a. Use the equation number 13. In the place of n, you have just m. K minus 2 pi m by a. So what happens now if you do it? K minus km, it becomes 2 pi m by a. That is what I have written here. So e to the power minus 2 pi imx by a into dx, integration 0 to a. Then you multiply e to the power minus ikmx to the next term. Here what you are getting when you multiplying? E to the power I kn minus km into x. What happens? Km is this, kn is this, subtract kn minus km. You are getting 2 pi by a into m minus n. See, this is what you are getting here. Right. So, sorry, here, yes. When you are considering to this, this is the term you are getting. Okay. So, here just summation sign left out, add it. Okay. Now, here gamma e to the power 2 pi m minus n of x by a dx is equal to 0. Now, how to integrate this? To integrate this equation, m is an integer. Consider m is equal to 0 first of all. When m is equal to 0, what happens here? First term, b naught into k naught square minus k square integration 0 to a e to the power 0 is 1, 0 to a dx. Integration of dx is x, upper limit is a. That is what you are getting here, right? So that is b naught into k naught square minus k square into a. Then what happens to the second? If m is equal to 0, you are getting integration 0 to a e to the power minus 2 pi inx by a. It is standard integral. Integration of this is equal to 0. Therefore, only equal to 0. So, from this you can get k is equal to k naught. That is the equation number 15 here. Now consider the second case. Here m is equal to 0 considered. Now you consider m is not equal to 0. If m is not equal to 0, again it is the standard integral here. Integration 0 to a e to the power 2 pi imx by a dx. That reduces to 0. First term reduces to 0. What happens to the second term? See, if m is an integer, n is an integer, m minus n is also a new integer, right? M minus n is equal to, say, q, right? E to the power 2 pi I qx by a. Again, that becomes a 0. But observe that there is one possibility, except m is equal to n. What happens, this equation? When m is equal to n, it becomes e to the power 0. Therefore, except for m is equal to n. So, only for this integral sustains. For all other values, the integral is 0. Therefore, for m is equal to n, the integration becomes integration 0 to a dx. Integration of that is x, limit is a. So, you can simplify it. Then you can rearrange the equation. For bm, you are getting minus b naught cm divided by k naught square minus km square. But previously, here just in equation number 15, you have written k is equal to k naught. Therefore, k naught is replaced by k. Or you can take this negative sign inside here. So, it becomes b naught cm divided by km square minus k square. That is the equation number 16. Now, what you have to do is, you have to substitute this equation number 16 in equation number 11. Substitute this. So, substitute the equation number 16 in equation number 11. Okay. So, equation number 11 is the expression for xi of x. Xi of x is equal to, right, b naught into e to the power ikx. Now, here negative sign is there, right? So, bm in the place of this, right? So, what happens? Gamma minus, because of this sign, minus gamma into e to the power ikx sigma, right? You have bn. This is the expression for bm. Just change the notation, that's all. bn is equal to, what you can write? Minus is already written, so b naught divided by k square minus kn square, then cn, right? In the place of cm, you have to write cn. So, cn into e to the power, in the expression you have minus 2 pi inx by a, right? So, this is after substitution. Now, what you do is b naught into e to the power ikx is common, take outside the bracket, then it becomes 1 minus gamma into sigma n not equal to 0, cn divided by k square minus kn square to e to the power minus 2 pi inx by a. This is the expression for xi of x is now. Now, this is the equation number 17. We will continue our discussion in next video lecture. Thank you.